Good morning, class. We are looking at Module 5, Chapters 10, 11, and 12. Chapter 10, Correlation and Regression. Chapter 11, Goodness of Fit and Contingency Tables. Chapter 12, Analysis of Variance. And here's Chapter 10, Correlation and Regression. So here's the question. Given the sample data, we have a small sample. Find the value of the linear correlation coefficient R. Test the claim that there is a linear correlation between the two variables x and y. Use both methods, method A and method 2. Method 2, I will explain that to you. Find the regression equation. Find the best predicted value of y when x is equal to 2. So let us discuss a couple of things. Scatter plots and the strength of a linear correlation R. A scatter plot is a graph of the ordered pairs x, comma, y. X, the independent variable, y, the dependent variable. If you have those dots, each dot representing a pair x, comma, y, this looks like a line going through it with a positive correlation. Distinct straight line or linear pattern, we say that there is a positive linear correlation between x and y, since as the x values increase, the corresponding y values also increase. If there is a strong positive linear relationship between the variables, the value of R will be close to positive 1. Generally speaking, 0.7 or larger refers to a strong positive linear relationship. Same thing here in a negative direction, called negative correlation. Distinct straight line or linear pattern. Again, we say that there is a negative linear correlation between x and y, since as the x values increase, the corresponding y values decrease. If there is a strong negative linear relationship between the variables, the value of R will be close to negative 1, negative 0.7 or smaller. So a number between 0.7 and 1 refers to a strong positive linear relationship. A number between negative 0.7 and negative 1 refers to a strong negative linear relationship. In this case, it's all over the map and there is no correlation, no distinct pattern, which suggests that there is no correlation between x and y. So when it's close to 0, there is no linear relationship. When it's close to 1, we have a strong positive linear relationship. When it's close to negative 1, as I mentioned, 0.7 to 1, and this is negative 0.7 to negative 1, a strong negative linear relationship. So correlation doesn't imply causality. That means it doesn't mean that it caused it. So correlation is between negative 1 and positive 1. Correlation between negative 1 and positive 1. Now let's continue with the question. Same question, we're going to continue. So here's the data, and the formulas involving this chapter are pretty involved. You don't have to do this by hand, but on purpose, I have picked a very small data to show you how the formulas work. So R, the correlation coefficient R, has the formula n summation of xy minus summation of x times summation of y over the square root of n summation of x squared minus summation of x quantity squared times the brackets n summation of y squared minus summation of y quantity squared. So what do we mean by that? I wanted you to see the process of getting the answer step by step in case you're curious as to what's happening. First and foremost, 1, 2, 3, 4. We have 4 pairs. That means n is 4. Secondly, let's write these columns x and y, and each one we're going to calculate. We're going to calculate x times y. So in this column, we have 1 times 2 is 2, 1 times 8, 8, 3 times 6, 18, 5 times 4 is 20. So that's the first column. Then the next one is x squared. So this column, the very first column, squared, 1 squared, 1 squared, 3 squared is 9, 5 squared is 25. The last one is y squared. So the second column squared. 2 squared is 4. 8 squared is 64. 6 squared is 36. 4 squared is 16. Now, as far as the summation sign, each column must be added up. So we're going to add those numbers. It becomes summation of x. This column summation of y. This column summation of xy. This column summation of x squared. And this column summation of y squared, this one. So we add them. Now we go with this formula and we say n is 4 summation of xy. So we look for xy, summation of xy is 48. So 4 times 48 minus summation of x times summation of y. Here's summation of x, 10. Here's summation of y, 10 times 20. So that would be the numerator. Square root. N is 4 summation of x squared. Find x squared. Summation is 36. Minus summation of x quantity squared. Well, summation of x is 10 squared. And then the same thing here, we do it with the y squared. So n, which is 4, summation of y squared, that means this number times this one, minus summation of y is 20 squared that. So please understand this formula step by step using what we did with this table. Take a look. Make sure it makes perfect sense to you. So what happens? We get negative 0.135. And again, it's done by hand. So the calculation of the numerator versus the denominator, and here's the answer with a bunch of decimals. So you want to go with many decimals unless they ask you to round it accordingly. Now, as I mentioned, you don't have to do this by hand. So what do? You have two pieces of data, x and y. So you need to clear list L1, L2, and put in to L1 and L2 x and y. We've done this before. So type in your data in L1 and L2, and then the linear regression t-test, stat test, linear regression t-test, enter L1 and L2, then leave the rest unanswered. Normally we go with 1. They have that. So in L1 goes the x coordinates, in L2 goes the y coordinates, and then linear regression t-test. X1 list is L1, the second one is L2, those we don't touch, and it's not equal when it comes to test of hypothesis, rho is not equal to, and you let it calculate, and it gives you a lot of stuff. With stuff, this arrow means go to the next one. Also, what we are interested for this page for now is just this number. So this one that we did by hand, of course, they have done it. And if we stop at the third decimal, next to it is 8, and it goes to 5. So it depends on how many decimals. Of course, we have many more decimals. Here's, for example, a calculator online. There are many online calculators you can use. All right, let's actually move on to the test of hypothesis steps. So to do the test of hypothesis, we are going to write what we found previously. We know n is 4, we know r is negative 0.135, and we are going to do two methods. Method 1, we go with the t-test, okay? And we have the method 2 that we use Pearson correlation coefficient. I'll discuss that in a moment. So test statistic has this formula, and H0 rho equal to 0. Rho represents the linear correlation for the population, or represents it for the sample. H1, rho is not equal to 0. It makes it a two-tailed test, and we go with the claim. Test the claim that there is a linear correlation. This means there is no linear correlation. If we go for H0, no correlation. If we go for H1, there is a correlation. So that's the first step, null and alternative hypotheses. Second step, so all these steps, test statistic, distribution, CV, critical value, rejection region, non-rejection region, and making a decision. So test statistic has this formula. Degrees of freedom is n minus 2. And so I want you to look at this formula. T is r squared of n minus 2 over 1 minus r squared. And please understand that this formula and this formula are identical depending upon the way you approach it. This is a basic algebra. By the way, mu sub r, just as before, means rho comes from H0, and it's always 0. I'm writing this formula versus this formula depending upon the text. Okay, you don't have to write mu sub r. Again, mu sub r is rho. And I hope you can see that if you multiply the r by square root of n minus 2 over 1 minus r squared, is the same as division by the reciprocal of that in this group. So please convince yourself these two are identical. This is elementary algebra. Now, what is r? We have it. Plug it in here. All you need, the value of r here, the value of r here, the value of n here when you plug in. So please understand these two formulas are the same. And again, you don't have to write mu sub r. If you write, this means rho, and it's always coming from H0. Therefore, the math ends up giving us the test statistic of negative 0.1927. As far as the second method that uses the Pearson correlation coefficient, just the value of r is used, because we use a t-table here, the concept of a t-test, and over here we use Pearson correlation coefficient. I will show you both tables again on the next page. All right, so now we got the first step, second step. The next one is the critical value, t-test, and alpha is 0.05. Generally speaking, alpha is given or not. If it's not, for cases like this, you always use the choice of alpha of 0.05. And degrees of freedom is n minus 2, or minus 2 makes it 2. The choice of alpha, if not given, is 0.05. Now, from the t-table or technology, we get t is plus minus 4.303. So the critical value for method 2 comes from Pearson correlation coefficient table. And the table gives us one number, and we make it plus minus because it's a two-tailed test, everybody. Whatever number that this gives us, we make it plus minus. So it's plus minus 0.950. So now we make a decision. To make a decision, we need to have a graph. So take a look at first the t-test, everybody. In the case of a t-test, look at this. You know this critical value is negative and positive 4.303, negative and positive. And test statistic is this number, which is negative 0.1927, way into the non-rejection region. So if you go with the t-test, of course, fail to reject H0. If you go with this method, you draw a line, everybody. You put these two numbers, negative 0.950 and positive 950 there, okay? And then your test statistic, which is the value of R, negative 1.35, ends up being somewhere in between these two numbers, which is a non-rejection region. So in essence, you have the bell-shaped here, you basically have a line here. And of course, they have to give you the same result, fail to reject H0. So when you don't reject H0, you're rejecting H1, you're rejecting the claim is therefore false. And now we do the writing. There is no linear correlation between the two variables. So if you go for this one, no correlation. If you go for this one, there is a correlation. As far as the technology is concerned, we've already done that. We've already done that. So I want you to see this number was done. Okay, this was done, and you can go to the previous page. And that was the t-test, and that's what they do. Also pay attention to the p-value, and the p-value is way larger than alpha over 0.05, which means don't reject H0 or fail to reject H0, which means no linear correlation. I want to show you how I use the table. For the case of a t-test, alpha was 0.05, degrees of freedom was n minus 2 or 2. So in the first column, we look for 2. And over here alpha is 0.05, area in two tails is 0.05. Put them together, and it gives you this number. And because it's two-tail test, you make it plus minus 4.303. The second method, okay, critical value n equals 4. So we have a Pearson correlation coefficient table, just as we have a t-table. N, for the left column, look for n is a 4. This is fairly limited, is for alpha 0.05 and alpha 0.01 mainly. So look for alpha 0.01. So this one, so this column and this column. When you put them together, gives you this number. It's a two-tail test, make it plus minus. So that's the way we got the R of plus minus 0.950. Continuing with the same question, regression equation. Regression equation is basically finding the linear equation that connects X and Y. Again, you're not expected to do it by hand because it's pretty complicated. But I remind you, we did this calculation. We chose a small data so we can see that, okay? Ultimately, it's y equals mx plus b, the slope intercept form. So y hat is b0 plus b1 x, or y hat is a plus bx, depending on the calculator, the technology that you use, a calculator, Excel, or others. And so as far as the calculation for the slope, here's the formula. The y-intercept, here's the formula. Y-bar, here's the formula. Y-bar is very straightforward. Adam of the y by n, x bar, the same thing. So according to this, we can calculate B1 with this. And remember, we have all of these calculations. So if I want to calculate B1, I need N, which is 4, times summation of X, Y. That means I have to multiply it by this number, 48. And then minus summation of X times summation of Y, multiply these two. Is that top? Then the bottom is 4 times summation of X squared is 36, minus summation of X, which is 10 quantity squared. That's what it's all about. So I hope it's clear to everybody. It's pretty straightforward if we have all of this. And so you do the math, you end up with this number. So we got B1. So in this formula, we got B1. Now we need to find B sub 0. B sub 0 is Y bar minus B1 X bar. So we need to calculate X bar and Y bar. And so X bar and Y bar is the summation of X. Remember, summation of X divided by 4 is X bar. Summation of Y, 20 divided by 4 is Y bar. So this one, we use number 20 divided by 4. And this one, we use number 10 divided by 4. See, basically every calculation is done for us. So the rest becomes fairly simple. And therefore, Y bar, B sub 0 is Y bar, which is 5. Okay, let's just write the formula, which is 5 minus B1. Okay, now for B1, we use this one, but with a lot more decimals. Times X bar. So I used, when we did the calculation here, we stopped here. We should really use the intermediate steps. Shouldn't, you should use a lot of decimals. Here's the answer. And according to this, we have B sub 0, we have B sub 1, and we write it. Therefore, Y hat is negative 0.182x plus 5.455 according. And this is in essence Y equals mx plus b. Also, we had done this previously anyways, okay? And I want you to see that we get the A, we get the B, and using A plus bx. So like I said, in some books or technology, they use Y hat equals B sub 0 plus B1x. This is the regression equation. Or Y hat equals A plus bx. We're going to use A plus bx. And notice the one we came up with and the one they have it, of course, with a lot more decimals. This is, in essence, done by hand. Find the best predicted value of y when x is equal to 2. Here's the general idea. Since there is no significant linear correlation, the best predicted y value is y bar. If we prove there is a correlation, we plug in. So we replace the x with 2. Since we prove there is none, no significant correlation, then y bar is the answer, which is 5. And of course, again, reminding you of the p-value that was done, which is 0.865, way larger than alpha 0.05. Failed to reject H0. That's what we have done as far as the correlation is concerned. So in essence, if you have no other part, this is the only part that you're doing. You look at the p-value, you say there is no linear correlation, and therefore you go with y bar. Again, just to give you the synopsis of why you would do this. Never mind the previous part that we went through, the test of hypothesis. The p-value here says there is no correlation, and the answer is y. A researcher is studying the effects of testosterone injection on different lab mice. She controls the concentration of testosterone injected into the mice and measures their metabolic rates. Analyze the following data set. Will you be running a correlation? or a regression. Find the value of the linear correlation coefficient R and test the claim that there is a linear correlation between the two variables, X and Y. Alpha is 0.05. As I mentioned, in many cases, they may not even mention that in science. So we are going to go with regression. Since she controls the concentration of testosterone injected into the mice and measures their metabolic rates, it's a control system. We want to see the effect. We want to see if there is an effect as far as the concentration of testosterone is concerned. Therefore, we must run a regression. Therefore, we can make a decision about causality and causation. So H0 rho equals 0, HA or H1 rho is not equal to 0. It's a two-tailed test. Now, what is rho equal to 0? There is no correlation between the two variables, meaning between the concentration of testosterone in mice and their metabolic rates. HA or H1, alternative hypothesis, there is a correlation between the concentration of testosterone in mice and their metabolic rates, and that is the claim. So obviously, we are not going to do this by hand. We're going to run it through technology. And when we go through technology, it gives us the following. It gives us this table. And what we are going to do with this table in the next page, we're going to work with this table, see what it means, and answer all the questions. So this is the table generated by Excel. So if we look at the table, we have the first step, of course, mentioned in the previous page. The second part is the test statistic. And according to method 1, we use this formula. It is the t-test. And here's the t-stat. So we write it, we don't have to. So it's important. I want to look at each part and tell you the meaning of it. So method 1 uses the t-test, and with the t-test or t-stat, this is the test statistic, this number. And of course, you can write all of them or just write. Based on the t-test, we are not going to go with the critical value, rather with the p-value, because the p-value is given. It's a two-tailed test where test statistic is here, and the p-value is 1.5316 times 10 to the power minus 15, which means you see this decimal? Go to the left by 15 places. So this is 1, and then 14 zeros, which is almost 0. This, we may not have a critical value, but it's way into the rejection region. So reject H0. As far as method 2 or R is concerned, we choose the R and it's done for us. It's this value, 0.9934. The number of data N was 17. N was 17, and from the Pearson correlation table, N is 17, alpha is 0.05. It results in plus minus 0.456. And if you draw a line, here's negative, here's positive, and this R is way larger than the positive. So here's negative 0.456, here's positive 0.456. This number is way into the rejection region. So whether we go with the t-test or the R using the Pearson correlation table, we have the same decision, which says reject H0 since p-value is less than alpha of 0.05, or if you go with this method, since the critical value for the Pearson correlation table is much larger than 0.456. So if you're rejecting H0, whether you're not rejecting the alternative hypothesis, which makes it the claim is true, and therefore there is a correlation. So we're going to write there is a significant linear correlation between the two variables. What does it mean? Therefore, we conclude that there is a significant correlation between the concentration of testosterone in mice and their metabolic rates. Since this is a regression study, the significant slope suggests that the increase in concentration of testosterone in mice causes increase in their metabolic rates. So significant slope, here's the significant slope. So I want to show you what those numbers are. So every number has a meaning. So we've discussed those. Okay, the p-value test statistic, and this is the intercept, and this is the slope, significant slope. And so, continuing with the same question, we want to find the regression equation. And again, I'm reminding you of those formulas, reminding you of what we came up with as far as technology is concerned. So what is the regression equation? We look at this, and remember, this is the intercept, this is the intercept, okay? So that's the intercept, is the slope. And so the formula is, you can think of y equals mx plus b, or ax, a plus bx, or b sub 0 plus b1x. So this is the slope, 199.05934. Okay, so 199.059, we stop at 059x plus 379.49, we stop at 2, we make it 3. That is the regression equation. Again, technology has given us everything. Find the best predicted value of y metabolic rates when x is equal to 1.3, the concentration of testosterone. We proved there is a significant linear correlation. Therefore, we plug in. So 1.3, plug it into x. And we predict it to be 638.2697, the concentration of testosterone. And x is 1.3. Using the above pairs and the value of R, what proportion of the variation in metabolic rates can be explained by the variation in the concentration of testosterone? In general, the answer is the value of R squared, which we, if we don't have it, this is the R squared, but it's given 0.9869 or 98.69%. So in general, okay, the portion of a variation in y, which is explained by x, is equal to R squared. Remember that, R squared.